So now we're going to do some stoichiometric calculations involving solutions. When we think about the composition of solutions, what we really want to do is quantify the solution concentration. Now, in this class, we're going to measure solution concentration in molarity. So molarity, also abbreviated with this big capital letter M, is a unit of solution concentration. And it puts the number of moles of solute over the number of liters of the solution. Now remember that the solution is the solute plus the solvent. So it's the number of moles of the solute over the volume in liters of the whole thing. So molarity, capital letter M, is also abbreviated as moles per liter. And it's implied that it's moles of solute per liter of solution. So for us, this is going to be our fundamental unit of solution concentration. And as you can see, it specifies the amount of solute in moles per unit volume of solution in liters. Okay. So the best way to approach this is to just do a whole bunch of examples. And I want to start by asking, what is the molar concentration that is a synonym for molarity? Molar concentration and molarity are synonymous. What is the molar concentration of a solution created by dissolving 25 grams of sodium chloride in water to produce the following volumes of solution? So we want to calculate the molarity when we make 250 milliliters of solution, when we make 500 milliliters of solution, and when we make 1,000 milliliters of solution. So let's go back to the question. For the molar concentration, we need the moles of solute over the liters of solution. And each question gives us the volume of solution, and we can convert that volume to liters by taking the relationship that I have 1,000 milliliters in a liter. So this is going to be 0.250 liters. That gives me the denominator for the molarity. Now I need the number of moles of solute. So what is the solute in this situation? That's always something you should ask yourself. What is the solute and what is the solvent? So sodium chloride here is going to be the solute, and the solvent, of course, is water. So that means I need to figure out the number of moles of sodium chloride because that's the solute. So there, I know I have 25 grams of sodium chloride. Looking it up in the periodic table, looking up sodium and chlorine, I can figure out its molecular weight, which is 58.4 grams per mole. And that will give me the number of moles of sodium chloride that I have. A simple gram-mole conversion like we did in the last chapter. So this is 0.428 moles of sodium chloride. Now, to calculate the molarity, I just take the moles of solute over the liters of solution. And that gives me a molarity of 1.71 molar. So I can use that big capital letter M to mean molar. I can also, it's equivalent to say moles per liter. Okay, you can say it either way. Big M for molar or moles per liter. Both of those mean molarity. So now, let's say I want to take those 25 grams of sodium chloride and instead I want to dissolve them in enough water to make 500 milliliters of solution. Well, there, the number of moles of solute is still the same, right? I still have 25 grams of sodium chloride. The only thing that's different is that I'm going to be talking about a bigger denominator. I'm going to have 0.5 liters in my denominator rather than 0.25 liters. So the molarity now becomes the same numerator divided by a larger denominator, and that is going to give me 0.855 molar for that solution. Now, notice what's happened here. When I doubled the volume of solution, I cut the molarity in half, okay? So doubling the volume of water from 250 to 500 cut the molar concentration in half because I doubled the denominator. The same thing is going to happen if I am looking to make 1,000 milliliters of solution, right? Once again, the numerator is the same. The numerator is just 0.428 moles. And now the denominator here becomes 1 liter. So this is 0.428 molar. And we can see that once again, when I doubled the volume from 500 to 1,000, I cut the molarity in half. Okay, so what I've done essentially is dilute my solution progressively.